Well, greetings to any and all of the good folks out there joining me today here on a fantastic Monday, because that's what we like to do on Monday. So we like to watch streams, especially streams that deal with math. So let's go ahead and get right to it. Greetings, Ulysses. Hope you're having a great day, great afternoon. Hope you guys had a good weekend. Seems that you guys are still out there and kicking it. I mean, kicking it good, if that's what the young kids are saying these days. All right. Ghost Killer, back for more. All right, so today we're going to talk about solving linear equations. You want to make sure that, to join us definitely for Tuesday and Wednesday of this week. We're going to be talking about factoring. So if you guys know me, you know how much I love to factor. Because make it a two-part stream because I know it's going to take a while. There's just a lot of good stuff to get through, a lot of factoring that we need to know, and a lot of factoring that we need to know going forward in this class. All right. So today's topic is about solving linear equations. Now, this is, to me, it's the foundation of all of the other solving of equations that we're ever going to come across in this class or in any other math class. You have to know how to solve the linear equations so that you can solve all the big, nasty, crazy equations, whether it's something that's quadratic, rational, radical, absolute value, you name it. This is where it all starts. So the thing to understand about equations, and this is the way I like to think about it, is that I see an equation as a math sentence. So an equation is just a math sentence. And like a lot of sentences that you come across or that you may speak, they may either be true or false. So if I say 5 plus 3 equals 8, I hope that we can all agree that this is a true statement. Right? 5 plus 3 is 8. No problem. But if I say 4 plus 3 is 8, well, we know this to be a false statement. But then we have statements like this. If I say x plus 3 is equal to 8, it's at this point that we can't say whether or not this statement is true or false. You're probably looking at this and you say, well, I know what I want x to be. I know what it's supposed to equal so that it is a true statement. But right now, we don't know if this is true or false. The big thing about solving linear equations is that it's our job to figure out what this should equal so that it is a true statement. Okay? So when we say we're solving, okay, to solve means to find any and all replacements of the variable so that the original equation is true. That's what it means to solve. So if you've ever been in my class, you know that I'm kind of a stickler for using the right words and the right terminology. So solving means that you're finding the replacement of the variable that's going to make the original equation true. And of course, those replacements are then called solutions. So if I look at something like x plus 3 equals 8, you're trying to figure out, all right, if x plus 3 is equal to 8, the big question on our minds is this. The big question is, what should x equal so that we have a true statement? So that's the thought process. What should x equal so that we have a true statement? Now, we already know what the answer is. A lot of times when we see some of these smaller equations, it's pretty easy to look at it and say, oh, if the variable is just replaced with this value, then it's going to be a true statement. And that's what we have here. We know that if x were to equal 5, then we would have a true statement, right? If I replace x with 5, then we know 5 plus 3 is 8. No big deal. Okay, so that's what it means to be a solution. But all this comes down to certain assumptions that we're going to make. So when I have this equation right here, and I say that x plus 3 equals 8, we start off with the assumption that this can be a true statement, and that we just have to figure out what is the replacement of the variable that will make it true. Okay? We assume that it's true, and if it's true, there are certain logical statements that we can make as we go through this to solve it. Okay? It's not a guessing and checking problem. Believe me, I've been there. When I was first learning how to do these guys, when I was a student, it took me a long time because all I did was guess and check. But there are properties that we have, and there's logic that we use, so that every step we take, everything we say has a meaning and has a purpose behind it. And so that's what we're going to look at here. Just refreshing you guys, first of all, about the addition property of equality. All right. So the addition property of equality says the following. It says that the statement A equals B is equivalent to A plus C is equal to B plus C. That is what the addition property says. It says that you can add the same amount to both sides and still have an equivalent expression. You can't just do that. If all you do is add C to one side, or you add a value to one side, you've thrown off the balance here. And that's the whole conversation that we're going to be having today, is that we are maintaining balance. So that what you do on one side of the equation, you're going to do on the other side. You have to maintain balance. Similarly, you would see this, that A equals B is equivalent to A minus C is equal to B minus C. So we kind of throw all of this underneath the heading of the addition property of equality, even though this technically would be the subtraction property of equality. But what we need to understand is that subtraction is just a form of addition. It's just adding a negative value, if you want to think about it that way. Okay, so with the addition property of equality in hand, we can then start solving these guys. And when we're solving these, again, every step we take, everything we say, there's a meaning and there's a purpose behind it. If you're ever in my class, you know that I don't just want the answer. I want to make sure you understand how we get to that answer. So if I take the equation x plus 8 is equal to 23. Our job here is to find the replacement of this variable x that's going to make this statement true. Now, we are assuming that this can be true. We are assuming that there is a value inside here that can make it true. And if it helps you out, maybe you think about it in a way they would have shown you a long, long time ago before they started throwing variables and letters into math. See, a long time ago, they would have just used blocks like that. And they would have said, okay, what number could you put in here to make it a true statement? And you would kind of work your way around to figure out what the answer is. But since we're doing algebra, it's not a guessing and checking thing. We go through it systematically, we have steps, we have procedures that we're going to follow. So there are two ways that we have of looking at this. The thing is, I don't want this 8 here. I want to get x, I want to get the variable by itself. Think of x like maybe it's you, or maybe somebody you know who is an extreme introvert, and they don't want anybody else around them. You've got to get rid of these guys. Because see, X is drained. X is an introvert, doesn't want people, right? Doesn't want anybody around them. So we've got to get rid of the 8. And the way that we counteract that plus 8 is by doing what's the inverse of that. So the inverse of adding 8 is subtracting 8. Now there are two ways of showing this. One of the ways that you'll see is that we will take the minus 8 and we'll just subtract it on the left side of the equation, and so that we can maintain balance, we'll also show subtraction with 8 on the right side, like that. Now, this is, some of you, this is how you do it. Others, maybe you see it a different way, but I want to point it out to you why we do this. So the reason we have subtracting 8 is because plus 8 minus 8 is now going to give you 0. We're trying to make sure that there aren't any extra pieces next to the x. So when you have x plus 8 minus 8, those guys are inverses of each other, so they cancel out to give us 0. And then on the right side, we just combine what we have. 23 minus 8 is 15. Okay? And so what we're saying here, whenever we box this x equals 15, we are saying that if we were to replace x with 15, we would have a true statement. And this is part of the, check your work that your teachers have told you to do so many times. So let's see that in action. So when we say check, we say replace the x with 15 and verify that what you have on the left side will be the same as what you have on the right side. And you can clearly see that 15 plus 8 gives you 23 on the left, which is what we have on the right side. So that is verified. The thing you have to be careful of is understanding that 23 is not the answer. The answer is x equals 15. It's that replacement of x that is the solution. The value that makes it true is when x equals 15. Now, what I said earlier is that we are assuming that this guy can be true. And the assumption that this can be true means that I can subtract 8 on both sides, and whatever statement I get below that is also going to have the same truth value as long as I do the same thing to both sides. If I subtract 8 on one side, but I subtract 7 on the other side, you're not doing the same thing on both sides, and so the truthfulness of the original equation has now been destroyed. But as long as you do the same thing on both sides, if this is true, then that's true, so that means x equals 15 is your correct response. Now, another way of showing this, which is how we're going to show it going forward, is that we tend to use a column format. At least that's kind of how we've learned to do it here in the States. So underneath the plus 8, we're going to do its inverse. So we'll do minus 8 underneath this, and we're going to do it on the other side as well. What you have to make sure that you pay attention to is your equal sign. So sometimes students like to do a dashed line like that so they make sure they understand the left side versus the right side. Because see, I've got minus 8 on one side, and I have to do the exact same thing on the other side. You can't do the same operation twice on the same side. What you do on one side, you do to the other side. And again, the minus 8 is not a mystery. The reason we do that is so that this stuff reduces to give us 0. So x equals 25 minus 8, which equals 15. Still the same answer, still the same work. It's just formatted just a little bit differently. That's all. All right? So let's do a few more examples. And as we go through this, most of the work is still going to be exactly the same. We're just going to be seeing different numbers. We're going to be reviewing, working with signed integers, because I know that's what we love to do. So let's do y minus 13 equals 19. Again, our job is to get the variable completely by itself. This is the only place that I see my variable. So in order to get that guy alone, I need to get rid of the 13. So we see a minus 13 there, and the inverse operation of subtracting 13 is to add 13. And we do need to make sure that we understand that the y and the negative 13 are two separate terms. They're not connected at all. When they are, We'll have to address that later. And again, if it helps, you can just imagine you've got this dividing line separating the left from the right side. So if on the left half I'm adding 13, I have to do the exact same thing on the right side. So I'm going to add 13 to the right. Again, you have to maintain balance. When you break the balance, then you get broken yourself. So here we have y equals, and this is just 19 plus 13. Add those guys together and we get 32. And it should be pretty easy to see that if I plug in 32, 32 minus 13 is 19. There you go. So far, so good? I'll take that as a yes. All right. Let's go ahead and get through some of these nice examples so we can get to the more complicated ones. The ones that make you feel alive. So 14x minus 87 equals 15x. Now, for the first time here, we have variables on both sides, on both sides of the equation. And so whenever this happens, we need to make sure that we get all of the variables to the same side. So one of the big picture ideas that we have is this. You are trying to separate with your terms to have variables on one side and to have your constants on the other side. That's one of the goals that we're trying to have. That way, you can get the variable completely by itself. But when they're on opposite sides like this, you've got to get them on the same side. Now, it kind of becomes your choice. Do you want to somehow get the 14x to go to the right, or do you want to move the 15x to the left? If you just take a moment to think about what's going to happen before you write anything, you'll be able to make really good, informed decisions. So, if, for example, I try to subtract the 15x and I move it over here to the left, that's going to create a void over here, it's fine. We just have to make sure that we remember to write a 0. But you don't want to put everything on the same side. When you are dealing with linear equations, variables on one side, constants on the other side, don't shove everything to the same side. We'll need to do that later when equations become more complicated, but not right now. So, I'm going to go with what you guys are saying in the chat, which is to subtract 14x on both sides. To me, that is the best thing because this is the only constant that I see. This is the only constant term, so leave him alone. Don't bother him. Don't poke the bear. Instead, move the 14x to the other side. So minus 14x on both sides. Make sure that what you do is actually going to work out. If I look at this, 14x minus 14x is going to give us 0, which is what we want. Okay? Don't say plus 14, because you want these guys to become 0x. So these guys become 0. So now I have negative 87, and on the right side, 15x minus 14x is just 1x. Now, a lot of times students want to write a 1 in front of this, and that's unnecessary. Please remember, in case you have forgotten, remember that 1x is the same thing as just saying x. So having a 1 there is not that important. All you need to do is get x by itself. We want to know what is 1x, and that's what we found. X equals negative 87. Now I know some people have an issue with x being on the right side, so if you want to, you can rewrite this to say x is equal to negative 87. It's the same thing. You can swap those guys around on either side of the equal sign, and it's going to be fine. All right, what do we have next? Oh, how about m plus 39 is equal to negative 14? Guys want to take a crack at that? What step should I take? Keeping in mind that this is the only variable that I have. No other variables anywhere else. So in order to get that guy by itself, what are you going to do? Right. So if I subtract 39 here, that's going to get rid of a constant. And I'm going to do that to the other side. Here's something else I need you guys to understand. I don't care what's on the right side of my equation. The right side of my equation means nothing to me right now. I'm going to subtract 39. I don't care what's over there. I don't care what's underneath my thumb. It could be a fraction, it could be a decimal, it could be a smiley face. I don't care. If I'm trying to get m by itself, I'm going to subtract 39. And now, these guys reduce to 0. I get m by itself. And then I've got to combine these two guys over here. Please make sure that you are paying attention to your signs. You have a negative and a negative. So, right now, even if you just have a basic 4-function calculator that doesn't even deal with signs very well, you should know what the answer is going to be in terms of your signs. If you were trying to combine a negative with a negative just by addition, which is really what we have here when we say combining, you're going to have a negative result at the end. If you lose 14 pounds and then you lose 39 pounds, you have a big loss at the end, right? And so what you're trying to do is you're trying to combine those losses. And so maybe off to the side, you understand what the arithmetic is. These guys have the same sign, so you're just going to add their absolute values, and we get 53. Since we're going to have the negative here, the answer is negative 53. So what I want you guys to understand is that even if you are left with just a basic 4-function calculator, you can still do it. You don't have to worry about how do I type in negative 14, how do I type in negative 39. You just need to understand that the arithmetic that you're doing is 14 plus 39. And these guys are both negative, which is why you have a negative as your final result. And there we go. Right? Not too bad. And this is where I lose friends. All right. So if I have x plus 3 over 4 is equal to 7 over 6. What am I going to do here? Or is this where everybody, leaves the stream because I put a fraction, right? I don't have to be here anyway. Yeah. Bye, Havoc. Thanks for stopping by. Now, I don't know if that's a sarcastic bye or not. If it's a real bye, thanks for stopping by. If it's sarcastic, come on, let's get through this. All right. So remember, this is what we're trying to solve for. Fractions, again, are just numbers. So regardless of what I have here, even if I do this, let's cover all this stuff up. You know that if I had x plus 3 equals something, let's do this. If I just have that, you would subtract 3 on both sides, right? Well, it's 3 over 4, so you're going to subtract 3 over 4 from both sides. Again, fractions are just numbers. So minus 3/4 and minus 3/4. And again, remember that this equal sign is acting as that barrier between the left and the right-hand sides. So if you want to put it there to remind yourself to be careful about the left versus the right-hand side, make sure that you do that. All right. Now with this stuff over here, go off to the side and do the work with fractions. So as we talked about on Friday, if we're going to add and subtract fractions, we have to have common denominators. So the common denominator for 6 and 4 is 12. Make a little note of that. The LCD is 12. And then we put in the missing factor so that we can combine these guys. So 6 is missing the factor of 2. So put that in the numerator and denominator. 4 is missing the factor of 3. And so now that we have common denominators, we can more easily combine these guys, right? So we get 14 over 12 minus 9 over 12, and all together, we get the fraction 5 over 12. So again, it doesn't matter that we have fractions. Even if we had decimals, the steps, the rules, the procedures are still the same, right? Don't let the scratch work over here, the working with the fractions, throw you off. We have to know fractions right now, right? That's what I'm assuming you guys know how to do. All right. Well, that was good. Feel good about the addition property? Let's go ahead and talk about the other main property that we have for solving linear equations. The other main property is the multiplication property. So the multiplication property of equality. Now I know it says multiplication, but we're also going to be throwing in a bit of division here as well, because division is a form of multiplication. All right. So the multiplication property says this. It says that if you have the equation a equals b, then this guy will be equivalent to and have the same truth value as this equation. That a times c equals b times c. Or if you want to think about it this way, you can do division with this. So a divided by c would equal b divided by c, but we've got to be careful about this. When it comes to multiplication and division, we have this extra statement here. This is all well and good, provided that that value that you are multiplying or dividing both sides by, provided that c does not equal 0. Okay, so you can multiply both sides of the equation or divide both sides of the equation by a number, as long as you're not using 0. 0 kind of ruins everything for us. Especially here, you can't divide by 0. Dividing by 0 gives us an expression that is what? You guys remember? Plus 5 imaginary points to those who remember. Oh, come on. You can type faster than that. Undefined. Thank you, Kevin. Appreciate that. All right. So, yeah, I thank you guys for saying undefined now instead of saying 0 like we did the other day. Hopefully you guys remember that neat little jingle, right? And it's not even mine. A student taught me that a long time ago, that when 0 is under the line, the expression is undefined. Yep. Anyway, so with the multiplication property of equality, you have things like this. 2x is equal to 26. Your job is to get x by itself. And the reason x is not by itself right now is because you have, multiplication right there. The x is connected to the 2 through multiplication, and the inverse operation for multiplication is division. So, to undo multiplying times 2, we divide both sides by 2. And we do that on both sides of the equation. Now, please be very careful. We're only dividing by 2. You only divide by the coefficient. Do not divide by x. If x is the variable that you're solving for, don't ever divide by that variable, just the coefficient. Because when you look at this, 2 divided by 2 gives us 1. So we were left with 1x, and on the right side, 26 divided by 2 is 13. So that is just a straight up direct application of that multiplication property of equality. What you do on one side of the equation, you do on the other side. Okay? Similarly, if I take this, if I say y divided by 8 is equal to 12. What do we do here? You see that you don't have y by itself because it's being divided by 8. So when it comes to solving these linear equations, and as we progress through these next few weeks, it's all going to be about doing the inverse operation. So what's the inverse of dividing by 8? The inverse is going to be multiplying times 8. So if I multiply the left side by 8, I'm going to have to multiply the right side by 8 as well. Now, please understand that when I'm multiplying times 8, I'm doing just that, multiplying times 8. That means this is 8 over 1. Okay? I know this kind of gets confusing because people think back in their minds about fractions, and this is why I want you to use proper terminology. So, on Friday, we were talking about getting equivalent fractions, and I would say, we're missing a factor of 2. And you might say, oh, multiply times 2. And then I corrected you and said, no, we're multiplying times 2 over 2. But here, I'm multiplying times 8, and 8 is 8 over 1. And the reason we do that is because 8 over 8 is going to reduce, and we just have the variable left. And then on the right side, we just do the multiplication. 12 times 8, again, this is going to stick with your basic 12 by 12 multiplication chart. So 12 times 8 is 96. So for the first problem, we had to use division to get the variable by itself. In the second equation, we use multiplication. But for both of them, we just do the inverse operation, and that's what's key, doing the inverse step. All right, let's do a couple of nice, quick ones to help us feel good, build up our confidence. 5x equals negative 45. I want to get the variable by itself, and right now it's not because of the 5. So, the inverse of multiplying times 5 is to divide both sides by 5. Again, we are not dividing by the variable. Maybe I should make that nice and clear for all of you. So, do not divide by the variable. Okay? Do not divide by the variable, just the coefficient. So, x is equal to negative divided by positive is a negative, and 45 divided by 5 is 9. Right. Not too bad. This is boring. This is going to put you guys to sleep. I should use larger numbers, right? Here, that's what all the cool kids are doing these days. All these TikTok videos, kids doing division with large numbers, showing off to their girlfriends and boyfriends. Yeah. All right. Negative 3w equals negative 54. To get the variable by itself, I've got to get rid of the negative 3. But you know what? I want you to compare this. I want you to compare that equation to this equation. Negative 3 plus w equals negative 54. I hope that we can see that these are not the same equation. Here, you have this understood multiplication between those guys when they're right next to each other. And we want to get the w by itself, so we divide, which is the inverse operation of multiplication. We divide by negative 3. And we do that on both sides of the equation. So now we have w equals negative divided by negative is a positive. Now I don't need to write the positive there, but I'm doing that as a reminder so I know that I have addressed the issue of the sign for my final result. And 54 divided by 3, when you do the math on that, you end up with 18. So here, w is equal to positive 18. Over here, though, getting w by itself is going to be a little bit different. See, the negative 3 is not directly attached to the w. These guys are two separate terms over here, so I don't want to mess with the w. I do want to get rid of this minus 3. So since the negative 3 is not connected and it's just the term minus 3, to get rid of it, this is where you would use a positive 3 because you're adding 3 to undo the negative there. Over here, this was connected through multiplication, which is why I divided by that coefficient. So, these guys reduce to give us 0. Over here, these guys reduce to give us 1 because it's division. So make sure you understand the difference between doing the division with the coefficient to get a 1 and adding with the additive inverse to get 0. So W is equal to negative 51. I hope that makes sense. I hope you guys can see the difference between those two problems. Okay. And let's go on to the next page because we need to make sure we have plenty of room for fractions. All right, so let's take 2/3. X is equal to 18. So regardless of what's on the right side here, our job is to somehow get rid of the 2/3. To get rid of a coefficient that's a fraction, you just need to use its reciprocal. So the reciprocal for 2/3 is 3/2. We're going to use the multiplication property and the reciprocal to get rid of this guy. So the reciprocal of 2/3 is 3/2, so multiply times 3 over 2. And we're going to do the same thing on the right side, multiply times 3 over 2. Remember, what you do on one side of the equation, you have to do on the other side of the equation. By using the reciprocal, the 2's reduce, the 3's reduce, so that all that is left is x. And on the right-hand side, we just have to take care of 18 times 3/2. And if it works better for you, just go off to the side. And let's rewrite this. Let's say that 18, let's write that as 18 over 1 times 3/2. Now before we multiply, let's see if there's any kind of reducing that we can do. And you'll notice that between the 18 and the 2, these guys can be reduced by a factor of 2, so we get a 1 here and a 9 here. So we have 27 over 1, which is just 27. See, even though it's fractions, it's still really not that bad. X equals 27. Now, I want to show you another way of doing this. It still does include the reciprocal, but not so explicitly. So let me show you another way. And maybe this works better for you. We'll just see. So another way of doing this is to first address the elephant in the room, which is the denominator, the 3. What you can do is that you can go ahead and start the equation by multiplying both sides times 3. Now, what I'm doing here is I'm going to knock out this denominator because this 3, again, remember, this is 3 over 1. Those 3's reduce, and I'm left with 2x on the left, and on the right-hand side I get 18 times 3, which is 54. And then, well, this is, we're on easy street now. Divide both sides by 2 so that we can get the variable by itself, and x is equal to 27. We still get the same answer. The only thing that I don't really care so much about this problem is that we deal with larger numbers, because we end up having to do 18 times 3 before we get to do dividing by 2. When we write it as fractions like this, and we look ahead to see if we can reduce before we multiply, the numbers don't get any bigger than 18. Well, I mean, over here they do, but the 2 reduces with the 18, so these numbers get smaller before you have to get bigger. And that's what I prefer you do. I prefer that you make numbers smaller before they have to get bigger. And we're going to see this again, later this week. So later this week we're going to talk about radical expressions and how to simplify those. And that's going to be on our stream on Thursday. So just a quick little PSA, all of the streams this week are going to be at 3 o'clock, and unless something happens here at the house, I need to change that. So come check it out. Like I said, Tuesday and Wednesday we'll be streaming factoring, and then radical expressions on Thursday, and complex numbers on Friday. Okay, let's do another one of these. All right, so let's take 15 over 28x is equal to 25 over 21. See, now you know we're having fun, right? Fractions everywhere. Are you asking, well, I'm not sure exactly how long the streams are going to be, probably until I feel like I've covered the material well enough. That's why the factoring one is going to be split over 2 days. Yeah, so most of the streams are going to be maybe an hour and a half, somewhere in between that. But good news for you guys, if you want to catch the streams later, I'm going to be uploading these videos to YouTube. And when I do that, I'm also going to be putting timestamps in the description below, so that if you have to jump out at a certain part, you can easily get back in without having to scrub through the whole video. So, like for today, I'll have a stamp for addition property, multiplication property, using both properties, maybe fractions, so you can just click on that and go straight to another video. All right, so for this one, again, here's our x, here's our introverted x who wants to be by itself. Okay, so, whoa, wait a minute. I do not want to divide 28 over 15 on both sides. That's going to cause us to do something a little bit different. And it's not going to do what you think it's going to do. So there are two things that we can do here. One of those is to straight up divide by this coefficient, so we can divide both sides by 15 over 28. Better than not divide by a fraction. Instead, let's do what we did in the last problem, which is to multiply times the reciprocal. So the reciprocal is 28 over 15. So let's multiply both the left side and the right side by 28 over 15. Now again, the reason we're using the reciprocal is because here on the left side, those 15s will reduce. 28 over 28 reduces, and I'm just left with x on the left side and what looks to be a mess on the right side. But that's okay, because we have all this room here on the side where I can go off here and simplify. Now remember what I said before. I said before you go big, go small. Look for factors that can reduce. And again, when we're dealing with fractions, you want to find a factor in the numerator that can reduce with a factor in the denominator. So as I look at this right now, 25 and 21 can't reduce. But 25 and 15 have a common factor of 5. So 5 goes into 25 5 times, and 5 goes into 15 3 times. So great, we've already made the number smaller. And then, if you look here, let's look at the 28. 28 and 3 can't reduce. However, 28 and 21 can reduce. They have a common factor of 7. 7 goes into 28 4 times, and 7 goes into 21 3 times. So we made these numbers a lot smaller. And now just multiply straight across. 5 times 4 is 20, and 3 times 3 is 9. And before you go on and say this is my final answer, make sure that you have taken the time to see if 20 and 9 have any common factors that you need to reduce away. But they have nothing in common, so that means we're done. So x is equal to 20 divided by 9. Improper fractions are okay for me as long as they are simplified. There is no sense in trying to convert this to a mixed number or a decimal. If you do that, so as a mixed number, you'd have to say 2 and 2/9. Or you could say that x is equal to 2.2 repeating. So if you do want to convert to a decimal, you have to be exact. At least for me, you do. Now later on, there will be situations where the instructions may say you just have to round to the nearest thousandth, or round to 4 decimal places, in which case you round accordingly. All right. So I think we're good on that. Oh, you know what? I want to go back to something that you said earlier, Ulysses, and what I was mentioning. if I take 15 over 28 times x is equal to 25 over 21. And if we want to say, let's do division. So divide both sides by 15 over 28 and divide this by 15 over 28. It's starting to look kind of messy. But it'll work. I want to make sure they understand that it will work. Now I want to rewrite this and say that this is 25 over 21. This is divided by the fraction 15 over 28. But we know that in order to divide by fraction, we keep the first fraction the same, the division becomes multiplication, and we end up multiplying times the reciprocal of the fraction we're dividing by. And so you see that multiplying times 28 over 15 is the same thing that I did up here. So it'll still work out. It just might be a little bit more cumbersome and maybe not as elegant. All right, so that's the multiplication property. Let's look at doing both properties together. Excuse me. All right, so when I say using both properties, I mean, let's take this. If I take 3x plus 11 is equal to 32. It's no longer a single-step problem like the ones we've seen on the first few pages. Instead, I have constants on both sides, and I've got a coefficient here in front of the variable. Again, your primary goal is to make sure that you separate your constants from your variables. Get those guys on opposite sides. So right now, since this is the only variable, let him stay on this side of the equation and move everybody else to the other side. So I'm going to go ahead and subtract 11 on both sides. This is a valid step to take. Again, we were trying to make sure that we take a balanced approach to things. There is that middle that is separating your left from the right-hand side. So now we have 3x on the left, equal signs, can't drop those because those are the verbs of our math sentences. On the right side, 32 minus 11 is 21. So we take one step and it takes this equation and it devolves it back into a nice single-step equation that we would have just seen. And so now our job is to get rid of the 3, get rid of that coefficient by dividing both sides by that coefficient. And now x is equal to 21 divided by 3, which is 7. That's it. One of the big things we're going to see here in math is that we have these really big, complicated equations. And we're going to take one step and make it smaller. Make it smaller and smaller and smaller. Every step we take, we're taking it back to something that we've seen previously. And that's how math works. Even with some of the things that look really complicated at the end of the semester, if we can get it to look like something we've already seen, they're going to be in good shape. All right, so 2x minus 57 is equal to 41. It's pretty much the same thing I have over here. Just want to make sure that we can see exactly what we're doing each step along the way. Recognizing that this is the only place I see my variable, I'm going to move things away from it, starting with the things that are least connected to it, that being the 57. So the inverse of subtracting 57 is adding 57. I do that on both sides of the equation. Again, I'm adding 57 because these guys are now going to give me 0. 2x is what is remaining on the left side. On the right side, we combine 41 and 57 to get 98. And now we're just one step away from finishing the problem. Divide both sides by 2, and x is equal to 49. Step by step, piece by piece, you get the variable by itself. It does not need to be a big deal. Okay? So as long as we're okay with these problems, that means I can add an extra layer to this, and we just have to figure out how to remove that layer to get back to the guys we're okay with. So let's take 5y plus 7 is equal to 43 minus y. What we're going to see now is that we have variable terms on both sides of the equation, and we also have constant terms on both sides of the equation. So we need to make a determination here. We know that we need to get all the variables together. You've got an option. We got two options. You can either try to move this y term to the left, or you can move the 5y and move it to the right side. Either way you do it, it doesn't really matter. You're going to end up with the same answer. You should anyway. So I suggest that you move your variable terms. Always move the variable terms first, and move them in such a way that you have a positive coefficient at the end. So in order to maintain a positive coefficient, we need to move the negative y from the right side over to the left side. So let's add y to both sides of the equation. When I do that, again, these guys go away to give us 0. That's the whole purpose of that. And now we have 6y plus 7 is equal to 43. And again, if you've got this dashed line through there so you can keep the left side from the right side, go ahead and do that. Once I added y to the left side, I've got all the variables on one side, and it looks just like the problems we have at the top of this page. So now our issue is to move the 7 to the other side. So I accomplished that by subtracting 7. These guys again become 0, which is what I want. I get 6y is equal to 43 minus 7 is 36. And the last step, divide both sides of the equation by 6. So y is equal to 6. So every step that we took here, I'm maintaining balance. If I change something on the right, I'm changing it on the left. If I change it on the left, I change it on the right, and so on, until at the end of the problem, all that remains is your variable. And it says that in order for this to be a true statement, that's going to be when y is equal to 6. Now, right now, we have equations that just have one single answer. But in the coming days, we're going to be looking at equations that have 2, 3, 4 solutions, maybe even more. Here is another way that we could have done this. So I know that a lot of you, depending on what you've seen, what you're comfortable with, you might do 2 steps at the same time, which is totally fine. And I want to do this for you. Instead of moving the y to the left, suppose you wanted to move the y's to the right side. So we're just going to subtract 5y and do that on the right side as well. Okay? Hope you guys can agree. Those guys go away. They become 0. Now, as I'm moving the variables to the right, the constants now need to go to the left side. So I'm going to subtract 43 now and move that to the left side. Now, you don't have to do 2 steps at once. If that's throwing you off, then don't do that. But I do want you to see that what we do on one side of the equation, we do on the other. This maintains balance. This maintains balance. 43 minus 43 gives us 0. 5y minus 5y goes to 0 as well. Here, positive 7 and negative 43 is a negative 36. Negative y and negative 5y is a negative 6y. And so we're here to finish this one. We're going to divide both sides by negative 6. And we get positive 6 is equal to y. It's the same thing that we had the first time we did the problem, except now we have the variables on the right side. But I don't want you to get stuck in thinking that the variable can only be on one side of the equation or the other side. Just pick a side. That's all you need to do. Again, my suggestion for you is to move your terms in such a way that your coefficient becomes positive. If you do that, it's going to be a lot easier to track where you're going and what you've been doing. And you don't have to worry about extra negatives running around. All right, let's take 2x minus 9 is equal to 7x minus 94. And so this kind of goes back to what I was just saying a few seconds ago. Move your variable terms so that you have a positive coefficient. So the easiest and best way to do that is to subtract the 2x over here, move it to the right side. You could subtract 7x and move it to the left, but if you do that, you're going to have a negative lead coefficient. Again, you can do that, but it seems like the more negatives that we have, the worse off we are. So I suggest to move the 2x from the left to the right by subtracting it on both sides. And if you want to, we can also go ahead and move the constant from the right to the left. But if that's making you uncomfortable and you want to show each step along the way, that is totally fine as well. So negative 9 is equal to 5x minus 94. And now this is the only place I see my variable. It's just like the problems at the top of the page. Move the constant to the other side. Yeah, I'll go ahead and use this color. So plus 94 and plus 94. Negative 9 plus 94 is 85. 85 is equal to 5x. So it took us a couple of steps, but now we're back at those single step equations that we had before. In order for us to get x by itself, we divide both sides by 5, and we do the arithmetic. Now, I tend to like to have my x on the left side, and I know that with the equal sign, the left is the right, right is the left, it doesn't really matter, so when we rewrite this, we'll say x equals 85 divided by 5, and we get 17. There we go. Do you guys have any questions so far, or is it all making sense? Trying to keep the numbers kind of nice and simple for us. Make sure we understand the concept, because it doesn't matter how large these numbers get. The concept is still going to be the same. Don't say, oh, there's fractions and I can't do it. That's a lie. It's just a different type of number. It's still a number, though. All right, where are we? You know what? Let's go ahead and be mean. I have no problems being mean to you guys. I want you guys to tell me the first step that you would take in this problem. X plus 4 divided by 3 equals 2x minus 1. What's the first thing you're going to do here? So what do you guys think? Is there something here in this problem that you don't like? Is there something you want me to get rid of? What do you guys think about that fraction? Would you like to get rid of it? Because I know how. Right, if I multiply both sides of the equation by 3, that takes care of this problem. Now you might say, what about this side? Well, let's see what happens. I'm going to take this entire side right here and multiply times 3. Multiply the right side of the equation times 3. Now, before we go on, I want you to see that what we're doing here is no different than what we did earlier in this stream. Okay? Earlier in the stream we had this. We had y divided by 8 equals 12. Right? And so for us to get rid of the denominator, we multiplied both sides times that denominator. It was gone, and I just took care of the right side, 12 times 8. Right? We're doing the same thing here, except now we have bigger, larger variable expressions. On the left side, understand this is 3 over 1. So those 3's reduce away. All that I have is x plus 4. This is one of the things that a lot of my students tend to miss, is that when I reduce the 3 with the 3, I'm left with a 1. This 3 doesn't even get a chance to distribute and hit the x plus 4 because he reduces beforehand with that 3 in the denominator. And that's why we have the 3 here anyway. On the right side, so equals, on the right side, you need to do distributing. Okay? The 3 is not just multiplying times 1, it's multiplying times the whole group. So 3 times 2x is 6x, 3 times 1, or 3 times negative 1 is negative 3. Now that the fraction's gone, now we can be happy, right? Because it goes back to the problems that we just did. Get your variables to one side. So I'm going to move my x to the right side, so subtract x on both sides. And at the same time that I'm moving the variables to the right, and sometimes you may need to make a note of this, you can say, I move my variables to the right, which means your constants now need to go to the left, making sure that you are putting these guys on opposite sides of the equation. So subtracted x, I need to add 3 to move the constants to the left, according to what I have right here. So plus 3. Those guys are gone. And now I have 7 on the left, 5x on the right. And now it's almost too easy, right? Divide both sides by 5 to finish the equation. Just for emphasis here, the 5's reduce. X is equal to 7 over 5. If you show work just the same way I'm showing work, you really shouldn't have any problems. I'm showing you every single step and not leaving anything out. Make it nice and clean, make it easy to follow. So any students out there, you're doing this for your teachers, make sure that your work is nice, make sure that it's neat, make sure that we can read it, okay? If it's all scribbles, ugh. It's like, what are we doing here? And I will let you know that my handwriting has not always been this neat. This has definitely been a work in progress. Oh, I'm not calling anybody out. I mean, I could. Maybe I should. All right, here we go. 8c plus 3 is equal to negative 1 minus 8c. So again, I've got variables on both sides. I've got constants on both sides. What am I going to do? Well, first, always move the variables, right? That is your primary objective, is to get the variables on one side. Don't worry about the constants yet. Focus on the variables. So if I move my variables to the right like I did above, that's going to give me a negative coefficient. So instead, I should move this over here to the left. So move the variables to the left, move the constants to the right. So I'm going to add 8c and add 8c. Please make sure that you guys understand. Okay, let's kind of do this division here. Understand that these two terms right here don't get to see each other until I take a step here using the addition property, which will essentially move this to the other side. Now we get kind of loosey-goosey with the terminology here, and we say move it from one side to the other. And what we really mean is that we are using the addition property of equality so that all of the variable terms are going to be on one side. And while we move the variables to the left, move the constants to the right by subtracting 3. Okay? And let's see what we have left. 8c plus 8c, those don't cancel. It gives us 16c is equal to negative 4 minus 3, and we get negative 4. All right, just one step left. Or do you guys want to go ahead and tell me in the chat what the answer is? See, I like doing problems like this just to see who's paying attention. What do you guys have? What do you think? Anybody? All right, so make sure that you understand you're getting the variable by itself. Right, good job, Ulysses. The trick, or the trap that a lot of students fall into is they see 4 and they see 16 and they want to say the answer is 4. I don't care what's on the right side. I care about getting the C by itself, which is to divide both sides by 16. Divide by that coefficient. Again, I don't really care what's on the right side. My job is to get the variable by itself. On the right side, I've got a negative divided by a positive, so the answer is negative. 4 over 16 is not 4. It reduces to be 1/4. It has a common factor of 4 in both the numerator and denominator, and that's what you are reducing. So we get negative 1 over 4. Cool, cool? Now let's look at some, I almost want to call these guys special cases, but just some things that you may run into and you need to be aware of them. If I take 3x plus 7 minus x is equal to 8 plus 2x minus 4. The first thing that I need to do here is I need to go ahead and bring all of the terms, I need to combine like terms. So on the left side of the equation, let's combine these guys. Okay, 3x plus 7 minus x, you can combine these two variable terms, and that gives us 2x, and then we have just plus 7. On the right side, I've got two constant terms, 8 and negative 4. So this becomes 2x plus 4. Now, as we were mentioning before, I said get your variables to one side first. And so we can easily do that by subtracting 2x from the right over to from the left to the right side. But notice what happens when I do this. This is going to give me 0, which is what we were supposed to get. But 2x minus 2x also gives me 0. And so what we have is an equation now that says 7 is equal to 4. But see, 7 doesn't equal 4. And so what we have here is that we have a false statement. See, we made the assumption here that this guy is true. And as long as this is a true statement, I can subtract 2x, I can do the same thing on both sides of the equation, and it's still going to be a true statement. But what I found out is that this is not a true statement, because all of a sudden the variables are gone, and I need to assess the statement that I have here, and 7 equals 4 is a false statement. And as Ulysses is pointing out in the chat, that means that there is no solution. Now, you need to make sure we understand what we mean when we say the words no solution. That means there is absolutely there's no value that you could plug into the original equation to make it true. Nothing's going to work. Nothing is ever going to make 7 equal to 4. 7 never equals 4. So there's no solution here. It's kind of a real shame because I was just starting to like that guy. But let's try this one. Let's try 4 plus x plus 1 is equal to 2x minus x plus 5. This is just like the last problem. Your primary objective here, again, is to get x by itself. But before we do that, we should try to clean up the different sides of the equation that we have. Because on the left side, there's some simplifying that we can do. Combine like terms, and we get x plus 5. On the right side, we've got 2x and minus x that can combine. And we get x plus 5. Wait a minute. this looks weird. This looks kind of funny. I think somebody's messing with us. If I try to subtract x from the right side and move it to the left side, I run into the same situation that we had in the last problem. I get 0 on the right when those guys cancel. I get 0 here on the left. And now I've got 5 is equal to 5. So the variables are gone. Does that mean it's now another no solution problem? And the answer is no. Because 5 equals 5, 5 equals 5 is a true statement. 5 is always going to equal 5. All the variable terms are gone. We have a true statement, which means the solution set is going to be all real numbers. That means that any value that you think of, any number that you think of, you can plug into the original equation and it's going to make it true. Because those variable pieces are perfectly balanced on the left and the right hand side. So 5 is going to equal 5. Things balance out always and forever. So this is going to be all real numbers. So that's the difference between having a true statement at the end, versus having a false statement that we had in the last problem. And this shows up again in linear inequalities and other types of equations and inequalities. And you have to be able to understand, what does true lead to and what does a false statement lead to. False is going to lead to no solution. True, well, there are a couple of different situations. But we'll eventually get to those later on. All right. So let's try 5 plus 2 times the quantity 7x minus 9 is equal to 4x minus 7 times the quantity 3 minus 5x. Hopefully you have enough room on your paper to write that. Here I am. I'm assuming that you guys are writing these problems down because that's the fun thing to do, right? A really interactive Twitch stream. You don't need me playing Fortnite, getting my, chicken lucky dinner things. Now, see, this is watching. This is participating. This is just like the last couple of problems that we had where we want to combine like terms on each side first, but I'm running into a bit of a stumbling block because I can't do that yet. I've got parentheses. I've got other things I need to take care of. But you've got to be careful. I know a lot of times I talk about these trips and these traps and pitfalls because I see students fall into them all the time. Do not combine 5 plus 2. See, 5 wants to get with 2. Unfortunately, 2 is connected to that set of parentheses. Multiplication is going to be stronger than any addition. So this 2 has to distribute first before it can even see the 5. So we have 5 plus distribute to get 14x minus 18. On the right side, this 4x doesn't get to see that set of parentheses. Only the 7 that is connected to that group will distribute. Alright, so just bring the 4x down. When you distribute, make sure that you understand that you are taking this negative 7 to distribute into these guys. So we get a negative 21, negative 7 times negative 5x gives us positive 35x. All right, so we addressed the issue of the parentheses and having to distribute, and now we need to combine like terms. All right, so this is the only x term that we have, so that's 14x, 5 minus 18. If you don't want to see it as 5 minus 18, and you just want to see it as, what is the better way of saying it, 5 and a negative 18. You gain 5, you lose 18, the net result is a loss, and it's a loss of 13 because these guys are going in opposite directions. On the right side, 4x and a positive 35x combine to 39x, and the minus 21 would just bring that down. Just like that. So we had to distribute, we had to combine like terms, But now it's just like those other equations that we did. You have variables and constants on both sides, and your job is to separate those guys, okay? So I want to move my variable terms, which way? Shout it out loud. Yeah, I'm going to move my variable terms from the left to the right. Now, you don't have to do this, but I hope you'll notice that if I subtract 14x on both sides, it gives me a positive coefficient over here at the end. And that's what I want. I don't want to deal with negatives if I don't have to. And once we do that, let's go ahead and move the constant term to the other side. So add 21. So make sure you understand what we did. Variable terms moved to the right. Constant terms got moved to the left. And if you didn't like me doing both steps at the same time, you don't have to. If you want to do just the variable pieces first, that's fine. And then in the next step, you'll have to address the constant terms. But I'm just trying to save space, and this is the way that I've always done it. So we get 8 on the left. 39 minus 14 is 25x. And now, the last step, just divide both sides by 25. You're not dividing by 8. I want to make sure we understand this. You're dividing by the coefficient, so we divide both sides by that coefficient. And at the end, x is equal to 8 over 25. Such a nice, pretty number. There you go. Getting that participation in the chat. Love it. Whew. All right. Are you guys ready for the challenge round? These have been too simple. There haven't been enough fractions. I know that's what you've been missing in your life. You want those fractions. Oh, man. All right. So let's do this. Let's solve two-thirds x minus 3/8 is equal to 7 over 6. Okay. Now, I don't want to have to deal with fractions for this whole problem. It's not like some of the other problems that we've had where we can just easily get rid of the fraction because it's only one little piece. You have fractions everywhere. And the best way to take care of this is to clear out all fractions, because here's this neat little statement that we have. And we'll do it this way. Okay. If you have two fractions that are equal, and these guys are the same. So if you have two fractions that are equal, you've got that same denominator, then the conclusion is that the numerators would then have to be the same. So what we're going to do is we're going to make sure that every piece in this fraction, or excuse me, every piece in this equation has the same denominator. And as soon as everybody has the same denominator, then we can just go from here, when they have the same denominator, to here. We can form an equation just from their numerators. So the big question here is, what is my common denominator? Here is what I think is the best way of tackling the common denominator when you just have three fairly small numbers. I would say take the biggest denominator that you have, 8. Does 3 go into 8 evenly? Evenly? No. Okay, so if it doesn't go into 8, go to the next multiple. How about 16? Well, 3 doesn't go into 16 evenly. The next multiple of 8 is 24. 3 goes into 24. Also, 6 goes into 24. So that tells us that our LCD is 24. We're going to use this guy. And here's what's really going on. We are multiplying both sides of the equation times 24. Okay? This is an application of the multiplication property of equality. Okay? But then there's distributing that happens here. So I'm going to rewrite this. So this is 24 over 1 times 2/3 x minus 24 over 1 times 3/8, and on the right hand side 24 over 1 times 7 over 6. Now this is one way. I'm going to show you a slightly different way. See, by giving you options, you pick which one works best for you. So the reason we want to pick the LCD is because look what happens. The 3 reduces with the 24 and it goes in there 8 times. So 8 times 2x is 16x. See, there's a reason behind multiplying times 24. Here, 8 reduces into 24 and it goes in there 3 times. So 3 times 3 is 9. And you know what? 6 goes into 24 as well, and it goes in 4 times. 4 times 7 is 28. See, the LCD is the least common multiple for your denominators, which means if you get a common multiple, that means all of these numbers can go into it evenly, which allows us to reduce, which means our denominators are just 1, and we don't have to worry about writing our denominators anymore. That's awesome. And so now, we just add 9 to both sides. So 16x is equal to 37. Divide both sides by 16, and x is equal to 37 over 16. Now, I'm not saying this is the prettiest answer in the world, but this is the answer. You would have gotten the same answer had you kept everything in terms of fractions up here, because at the beginning you could have added 3/8 to both sides. Then you would have run into the issue of having to get a common denominator to combine them, and then you would have had to use the reciprocal of 2/3 to get rid of that. But instead of taking all those steps with fractions, I do one step. I get rid of my fractions, and I'm done. And it really doesn't take that long to do it. Now I want you to see another way of approaching this problem. It still requires the use of the least common denominator, but we're going to use it in a slightly different way. Okay, so by identifying that the LCD is 24, I want us to rewrite all of these fractions to be equivalent fractions with denominators of 24. So, what's 3 missing to be 24? He's missing the factor of 8. 8 is missing a factor of 3. And 6 is missing a factor of 4. Now, notice what I'm doing here is I'm taking these guys one fraction at a time to get the equivalent fractions that have a denominator of 24. Just to check, though, that gives me 24, 24, and 24. So I end up with 16x over 24 minus 3 times 3, so that's 9 over 24, is equal to 7 times 4, 28 over 24. Now the purpose of me doing this is so that we can apply what we have up here in blue. All of these denominators are the same, which meets this initial condition. And if all of the denominators are the same, then we can form our equation from just the numerators. So 16x minus 9 equals 28. And you see that's what we have over here. You take the steps, and you would still end up with the solution x equals 37 over 16. And so I like to clear my fractions because not that fractions are bad and not that we can't work with them, but it makes the problem a lot easier when they're not there. But the thing is, you can't just erase them. You can't just pretend that they don't exist. I think that's what a lot of people want to do. All right. I think this would probably be a good one to end it for the day. Let's take 7 over 8 plus 1/2 x minus 2 is equal to 13/16 x plus 5/4. Don't let extra pieces, don't let extra numbers intimidate you. Understand they're just numbers, it's just part of an equation, and you can still do this. Okay? Since we have a bunch of fractions, I suggest that we try to identify the LCD. Again, start with the largest denominator that you have, the 16. Does 8 go into 16? Yes. So I don't have to worry about the 8. 2 goes into 16, 4 goes into 16. Yeah. I guess I made it a little bit too easy. So my LCD here is 16. Now, I'm going to do something that I don't normally do. And for emphasis, I'm going to write the 2 as 2 over 1. It's not necessary, it's not mandatory, but it might help us out for the next step. You've got two options that I just showed you. I said that you can either turn all of these denominators into the LCD, or you can multiply each term times the least common denominator. It's really up to you. So, let's try to multiply everything times the LCD and see what happens. So, I'm going to multiply this times 16, and this guy, and so on and so on. And let's see what happens here. So I'm skipping that distributing step where I was putting everything in parentheses because I know that it's going to distribute. So I'm going to go ahead and multiply everything times 16. If I've done this right, all of these denominators are going to reduce. And you'll see here that 8 goes into 16 twice. And now 2 goes into 16 8 times, well, that's just once, so who cares? 16 goes into 16 once, and 4 goes into 16 4 times. And so let's write what we have left. 2 times 7 is 14. 8 times 1x is just 8x. Minus, don't forget your sign here, 16 times 2 is 32. 1 times 13x is just 13x. And then 4 times 5 is 20. All the fractions are gone. Everybody should be happy here. Let's go ahead and clean up this side over here. We've got 8x, and 14 minus 32 is negative 18. Nothing to combine on the right side. And now it's just a matter of get the variables to one side, get the constants to the other side. So here I'm going to subtract the 8x from the left to the right side because I want to have a positive coefficient. So let's subtract 8x. And then I'm going to move my constant from the right to the left. And so now we have negative 38 is equal to 5x. And now we just have one step left, and that's to divide both sides by 5. So x is equal to negative 38 over 5. Now I want to show you that second method that we did just so that you have another example to see how do we go about getting everybody to have a common denominator and then kind of ignoring those guys. Alright, so let's take that same problem, 7/8 plus 1/2 x minus, I'm going to go ahead and say this is 2 over 1 just to make it easier for us. 13 over 16 times x plus 5 over 4. We know the LCD is 16. Put in the missing factors. Now when you do this, it's fraction by fraction. It's not for the whole problem. Make this guy to be equal to 16, so he's missing a factor of 2. This guy's missing a factor of 8. This guy's missing everything. He's missing all of 16. 16 is not missing anything, and 4 is missing a factor of 4. And so when I work this out, I have 14 over 16. I have 8x over 16 minus 32 over 16. This guy didn't change. So 13x over 16. And then finally I have 20 over 16. Now here's what I want you to notice. I want you to see what we have in the numerators. You have 14 plus 8x minus 32 equals 13x plus 20. And you'll see that's the same thing that I have up here. So once everybody has the same denominator, we can then rewrite that as its own equation. Just take those numerators, that's your equation, and when you solve this, you're going to get the same answer that we had above because the math did not change. X is going to equal negative 38 over 5. Whew. Looks like a lot of work. It takes practice. Piece by piece, you can do this. It's really not that bad. Alright, so we're going to cut the stream right here. We've done 6 or 7 pages. I hope that this was informative for you. I hope maybe this kind of refreshed some of those skills, and now you know, alright, we're good. We can solve these linear equations. It's not a problem. Remember, I'm going to be uploading this to YouTube here this afternoon. Put some timestamps on there, so if you want to share it with people, maybe you've got some, some friends that are taking, college algebra or any of the other math classes, or maybe, who knows, you might even know some kids or cousins that are just now getting to this stuff and some of the classes that they're taking. And if you think this would be helpful to them, please feel free to share this. Again, you can always find me anywhere you see Mathman1024. So you can find me on youtube.com/Mathman1024. Of course, you found me here on twitch.tv/Mathman24. And again, look for me for the next, for these next 3 weeks, 3 o'clock, I'll be streaming and then uploading those videos to YouTube. So appreciate you guys stopping by. Hope you have yourselves a great afternoon. Stay safe out there. And remember, what would Mr. Craig do?